Number sense and ratios. Which of the following would save more fuel? Show work to prove your answer. First option, choice A, would replacing a compact car that gets 46 miles per gallon with a hybrid that gets 60 miles per gallon save you more than replacing a sport utility vehicle, SUV, that gets 17 miles per gallon with a sedan that gets 32 miles per gallon? To see which one is a better switch, you need to put them on the same equal playing ground. So if we were just to think of a number of miles, number of set miles that each one were to drive, then we can compare how much we would save from one switch to the other. So taking the compact car, let's just use the number 100. I'm just picking a number. If I traveled 100 miles in a compact car that gets 46 miles per gallon, then I would use 2.17 gallons approximately of gas. Now, if I took that same 100-mile distance and traveled it in a hybrid that gets 60 miles per gallon, this would utilize only 1.67 gallons of gas. Taking these two numbers here, I can subtract them. 2.17 minus 1.67 gives me 0.5 gallons of gas difference. So it's this much that I'm going to save if I switch from this compact car to this hybrid. I will save this much gas. Okay. I'm not done yet because I want to know how much this switch will save me. So once again, I'm going to start out with 100 miles traveled. I just picked the number of miles, but it all needs to be the same, the number of miles, so we can have them on the same playing ground. 100 miles traveled with a vehicle, an SUV that gets 17 miles per gallon, will utilize 5.88 gallons approximately. But if I'm traveling that same 100 miles in a sedan that gives me 32 miles per gallon, I'm going to use 125, I believe, gallons of gas. Now from here, I'm sure you can see that if I'm using 3.125 gallons for one vehicle versus 5, I wrote that backwards. I didn't mean to have it in negative. The difference between the two is that I'm going to be saving 5.88 minus 3.125. This one saves me 2.76 gallons. So from here, which one of these choices saves me more gas? Choice B. Because choice B right here saves me more gas in this switch. So I'm going to write choice B. Number sense and scaling. Elijah builds a miniature model of a car based on the dimensions of a popular car. He uses a scale factor of 1 foot is 2/10 of an inch. Determine the length of the miniature model if the actual car is 13.5 feet long. If I set up my scale factor proportion, I've got 1 foot as my scale to represent 2/10 of an inch. If the actual vehicle is 13.5 feet in length, then finding the model length would simply be found by cross multiplying. When I cross multiply here, I get x to equal 2.7 inches. Again, I just cross multiply, and this way right here is 1x. And when I multiply here, it gives me 2.7. So the length of the miniature model should be 2.7 inches. Laura made a scale drawing of a famous monument. She used a scale factor of 1 inch is 1.6 feet. If the height of the monument in the drawing is 17.4 inches, then compute the actual height of the monument. Well, I'm putting my 17.4 inches up here with the model, and then solving for x here will involve me cross multiplying once more, and that would be 1x is equal to 17.4 times 1.6. 27.84 feet in actual length for the monument. The next two problems are giving you simple scales with an actual model, and it's been measured for you. So just set up your proportions again here and cross multiply. For this one, I've got 1 inch is 3 feet, so that's 1 inch over 3 feet. And it gives you 1 point, or sorry, not 1 point, but 15 inches for the height of the model. Set your x here, cross multiply. Actual height of the tree, 45 feet. One inch represents half of a foot. So 2.34 inches would represent how much of a foot? Cross multiply. 1.17 feet in actual length of the seahorse. To identify scale factor, we want to remember our ratio of new over old. So then that means I would take the measurements of my new figure and write it in the ratio to my old figure. From looking at this picture, figure R appears to be my old, and figure S is my new. Just pick any two proportional corresponding sides. So I could take 6 over 4. I didn't mean to say 6 over 4. I meant I could take these two measurements here, or I could use these measurements here, or I could use these measurements here. All of them will give me the same resulting answer as long as I set it up with my new over my old. Okay, so that means I would take, I'll just use the ones in red, I guess. 5.5 is my new, and 8.8 is my old. My scale factor is 0.0. Oh no, sorry, there's not a 0 there. There's 0.625. And you see here that that makes sense because this figure went from large to small. If your figure reduces in size, then your scale factor is a reduction, and that means your scale factor should be less than 1. Remember, if our scale factor, K, is less than 1, then that is a reduction. If it's greater than 1, it's an enlargement. That takes me to question 6. What happens to the new image if the scale factor of the original image to the new size is 2.5 to 1? Again, 2.5 is greater than 1, making it an enlargement.